There we go. Okay, so 5 through 18 was fine. There were no issues on any of them. There was no funky problems. 5 through 18, nothing went weird on us. Okay. And then for the notes last night, we finished the back part. We did X and Y intercepts. We learned that with the Y intercept, there's just going to be one answer. But with the X intercepts, there could be multiple. So there could be one, there could be two, there could be three. In a crazy, crazy graph, there could be like 57. But we're not going to see any graphs like that because I'm not crazy. So we're just going to see, was that a so we're just going to see a couple. And then continuity just means that you can trace the graph with your finger and not pick your finger up. These graphs are always continuous. So if they ever ask, we just say yes. Yep, I can trace it without picking my finger up. And then we learned end behavior is just describing the arrows, but it's doing it fancy like with math notation. So this is probably going to be the most difficult part of today is describing the arrows. So we're going to finish the front side of the worksheet, and then we're probably going to have the most questions on the back of the worksheet because the back of the worksheet is totally different than our notes. So those of you guys who are finishing up your notes, you're going to want to make sure you get your notes done so that you can participate with us on the back. Okay. So anybody who did not take their notes last night, you are getting your notes done now. They're only 7 minutes long. You're getting your notes done now so that you can participate with the back side of the worksheet. Okay. So doing the front, we have to find the intercepts. What should we do? Well, Miss Rice, you should put it into Desmos. Okay, let me get on Desmos. Okay. And we're typing y equals x to the fourth plus 4x to the, 4x to the third plus 4x to the second minus 5 minus 2x. Is this problem written in the right order? Look at number 1. Is that written in the right order? Number 1. Is this how we normally see problems written? No. What's weird about it? Desmos will graph it just fine. It will not graph wrong. But what's weird about this problem? Can anyone see what's weird about it? Something's weird. Normally, the negative 2x would be written before the negative 5. So they wrote it out of order. But Desmos can handle that just fine. Okay, so let's look back at the graph. How many y-intercepts do we have? 1. We should only ever have one y-intercept. So right down here, the extra gray dot that you see right down there is the valley. That's the minimum. So we don't need that for this problem because they didn't ask for it. So our y-intercept is 0, negative 5. I'm going to go ahead and write that down. And then how many x-intercepts do we have? How many x-intercepts do we have? 2? 2. So x-intercepts negative 2.286 and 0.899. So these first 4 questions are going to go pretty quickly because you're just finding x and y intercepts. So those are relatively easy. And then when you guys are done with 1 through 4, you're going to jump down to 19 through 22. You're going to state whether each of those graphs is continuous. What's your answer for if the graph is continuous or not? They say, is the graph continuous? And you say, yes, every time. Every time you just say yes, because these graphs are always continuous. And then when they ask about the end behavior, I can help you guys with those in a little bit. So let's go ahead and do 1 through 4, and then we'll come back and look at the end behavior ones together. Make sure we can talk about our arrows and make that part make sense. Okay. So if we look at the bottom problems, we're still going to have to graph those because we do still need to know what they look like. And then we're going to be describing the arrows. So let's go ahead and type number 19 in. And just like we did for the domain and range and for the increasing and decreasing, we're going to draw a little sketch first. And then we're going to go ahead and figure out how to describe the arrows. So I'm just typing in 19 and I have enough right here so I can draw a little sketch. Okay, looks like that. Let me show you what I've got drawn. Okay, so I just drew a little sketch. So if we were to talk about the left arrow, what do you guys notice about the left arrow? Does it go up or does it go down? Goes up. Okay. And then what about the right arrow? Does it go up or does it go down? Goes down. So what we're going to say is we're going to write in math notation. We're going to say the left arrow goes up, the right arrow goes down. Okay. So if you look at your notes, do we remember how to say left arrow? If you look at your notes, how do we say left arrow? Because in this description, something says left arrow, something says right arrow. So we have to remember which one says left arrow, which one says right arrow. And is it the part that uses X or Y? X. So this part right here in your notes, this means left arrow. That's what that means in your notes. So if you need to go back and edit your notes so that you remember what that means, you can go ahead and do that. So if we're going to describe the left arrow, we're going to say as X goes to negative infinity. This is us talking about the left arrow. And if we want to say that the left arrow goes up, we're going to say that Y goes to, and then which infinity are we going to use for up? Positive or negative? Positive, because positive is up, negative would be down. So we're going to say Y goes positive because Y goes up. So the left arrow is up. X is left or right, Y is up or down. So X is negative, Y is positive. Left is up. The left arrow goes up. Okay. If we want to say that the right arrow goes down, I'm going to say X is positive because I want to say to the right arrow. And if I want to say that the right arrow goes down, how do I say that? Y goes to negative infinity. So the right arrow goes down. X positive means right. Y negative means down. So this is us saying in math notation, the left arrow goes up, the right arrow goes down. Okay, so go ahead and graph number 20 on Desmos, sketch a graph on your paper, and then let's see if we can accurately describe the arrows. And I'm going to come around and check and see how you guys are doing. Okay, so our drawing looks like this. We're always going to start talking about a left arrow and a right arrow. So the beginning part is always the same. You always write that the same. As X goes to negative infinity, as X goes to positive infinity, because you always have a left arrow and a right arrow. Or you usually have a left arrow and a right arrow. And so then we just have to say what they're doing. So what do you guys notice about this picture? What are both of the arrows doing? They're going down. So we're going to say Y because Y is telling us up or down. And if they're both down, what should we write for both of these answers? Negative infinity for both of those answers. So we're going to say the left arrow, x to negative infinity, the left arrow goes down, the right arrow goes down. Left arrow goes down, right arrow goes down. All right, go ahead and try 21 if you haven't tried 21 yet. So if you look at 23, they ask a couple questions, and we just want to make sure to start with that we understand what the questions are. And I think this is the first time we've really covered these together. And so we're going to kind of use number 23 as notes. And I like to use colors on these. That will probably make your guys' lives easier too. So let's go ahead and go get, you can use colored pencils or markers or whatever, but let's go ahead and grab some colors so that we can make these problems make sense. And you can use, you'll need 3 colors to do the problem. So go ahead and grab 3 colors that you're going to use to do the problem for 23. We're going to use 3 colors. Isaiah, you have your notes from last night. So you need to take your notes. Perfect. Thank you. All right. So in 23, they're asking you a lot of things about f of x. So up here, they tell you f of x equals this equation. And f of x is just a really fancy way of saying y. It's just function notation. It says the function in terms of x. So it's just saying if you plug in these x values, or if you're writing something in terms of x, that's what your output is. That's what your y is. So let's go ahead and cross out f of x and put y. And so they're really talking about y here. Where is y greater than or equal to 0? Where is y negative? Where is y equal to 5? And all these questions, they're just asking about the y coordinates. Does that make sense? Where is y doing something? So if you're answering a question about where is y doing something, the answer to that is going to be an x value. Where is y doing something? The answer to that is going to be an x value. So if it says where is y greater than or equal to 0, let's go ahead and label where y equals 0, where y is greater than 0, where y is less than 0. Okay, so that we just know on the graph where to look for all those points. So where does y equal 0? What are those points called where y equals 0? Yeah, intercepts. And they're called, are they the y-intercepts or the x-intercepts? Where y equals 0. They're the x-intercepts. So use one of your colors. We're going to have 1, 2, 3 of them. So we're going to say that these are the places where y equals 0. The x-intercepts are the places where y equals 0. So let's go ahead and graph this on Desmos. We want to see where those places are for this particular graph. So we've got y equals negative x to the 5th plus 4x to the 3rd minus 2x minus 1. Oop. Zoomed in a little bit too much. There we go. Oop. Okay. So right here, and right here. So I'm just going to label that on my drawing. Well, not drawing, but I guess it was printed. So 1.789. And let me show you guys how I'm labeling it so you can label it in a similar way. I'm just labeling it like this so I can see where the numbers are. So that's 1.789, 1, and then the other one was negative 1.895. Okay. Now we have to think about where the y values are. The way they say it up here is greater than 0, and where y values are negative. So I'm just going to use Desmos to kind of help me think about this picture. Where are the y values positive? Where are they negative? Let me zoom out. Is this image? I'm not very good at zooming in and out slightly. Okay, so if I trace this, now if you guys look at the y values, what do you guys notice about the y values where I am using my cursor right now? What do you guys see about these y values? Just the y values. What do you guys see? They're decreasing. What about the numbers? Are they positive or negative? They're positive. Okay. What about these y values? They're negative. Okay. And if I keep going, what about these y values over here? Negative. So I still have negative y values. Okay. What about up here? What y values do you guys see right now? Positive. So these are positive y values. And then if I go over here, what do we see over here for y values? Negative. So if we were to summarize what we just noticed, where do the positive y values show up? On the top. And where do the negative y values show up? On the bottom. Okay, so let's draw that in our picture. The positive y values show up on the top, and the negative y values show up on the bottom. So I'm going to do mine in purple. I don't even know. Can you see that? Kind of. So positive y values. Positive y values are always above the x-axis. So the x-axis is that line right across the middle, and the positive y values are going to be above it. And then the negative y values are going to be below it. So negative. Okay. So we labeled where y equals 0. And where y equals 0 is an x value of negative 1.895. It's an x value of 1. It's an x value of 1.789. Let's label the x value right here. What is the x value of a left arrow? What is the x value of a left arrow? Negative infinity. So we know that the y value is positive infinity because the arrow is pointing up. But the x value is negative infinity because this is pointing to the left. So negative infinity because it's a left arrow. This is a right arrow. It's the right side of the graph. So if it's a right arrow, which infinity is it? Positive infinity. It's a right arrow. Okay. All right. So if we're going to write the answers for A, B, and C, for A, it says, where is Y greater than 0? Is greater than 0 going to be the positive Y values or the negative Y values? Greater than 0. Positive Y values or negative Y values? Or greater than 0? Positive. Okay. So I'm going to circle this in the same color that I used there because that's the part that we're going to use for the answer. So if I have to use the values that described the purple, then what x values should I use to describe from here to here? What x values describe from here to here? Okay, so A is going to be negative infinity to negative 1.895. Okay. Whenever we use infinity as an answer, we always use a parenthesis with it. Now, the negative 1.895, we have to think about whether or not that answer should be included. So this says use the y values that are positive or that equal 0. If you plug this answer in, is it going to be positive or equal 0? When I put the dot right there, what did the dot mean? It equaled 0. Okay. So is this number going to give you something that's positive or equal 0? Yes, because this dot represented what equaled 0. Okay. So we're going to put a bracket because it gives you something that equals 0. Okay. Now we have to do the other purple answer, which is from here all the way to here. What two numbers does that use? One and then 1.789. Okay. And then again, the instructions say use the values that are greater than or equal to 0. If we take this number and plug it in, what did it give us as an answer? 0. Is that greater than or equal to 0? Yes. Okay. So we use a bracket. If we take this number and plug it in, what does it give us? 0. Is that greater than or equal to 0? Yes. So we use a bracket. Okay. These are not points. These are not X and Y coordinates. This is an X value to an X value, an X value to an X value. You have to use both answers to be correct. So if that's the case, what should I put in between? A U. What does the U stand for? Union. Okay. Whew. Okay, that was tricky. All right, let's do the other answer. The other answer says, where is f of x negative? So which one are we using this time? The green. We're using the green this time. Okay. We're using the green this time. All right, so this time we're going to go from here to here. So let's write these numbers down. Starting here, going here. So what number should I write first? Negative 1.895. That's the first number. The second number is 1. Okay. Now, if I plug in negative 1.895, what's my answer? What do I get out? 0, okay? Is 0 a negative value for y? No. So should I put a bracket or a parenthesis? Parenthesis, okay? If I plug in 1, what do I get for y? 0. Is 0 a negative value for y? No. Parenthesis. See the difference between the brackets before and the parentheses now? So before we had 0 as the answer that y could be, so we put brackets. Now we have only negatives as the answer that y could be, so we're putting parentheses. Okay. All right, we got one more answer for green. So where does this answer start? 1.789 to infinity. Okay, infinity always gets a parenthesis because you're never going to be able to plug a number in and get infinity as an answer, right? Your calculator never puts the infinity sign. It gets really, really big, but it never actually spits out infinity as the answer. Okay. If we plug in 1.789, are we going to get, we're going to get 0 as an answer, right? Is 0 a negative number? No. So we're going to put parenthesis. All right. We need both of these answers. So what do we put in between? U. Okay. All right. How are your brains feeling? That was a wild problem. Okay. We're not going to do too much more. We're going to put an X through 24. We're going to put an X through C. We're going to jump down to 25 because 25 is really similar to 23. All right. So it says, where does f of x equal 0? Where is f of x positive? Where is f of x less than 0? So the first thing I'm going to do is just remind myself f of x is just a fancy way of saying y. So I'm going to get rid of all these f of x's and just remind myself, yep, these are all y's. And then I'm going to go ahead and grab my colors. And let's find all the places where y equals 0. So y equals 0, what are those called? What do we call those? Not y-intercepts, x-intercepts. Okay, so we got an x-intercept here, x-intercept there, x-intercept there. Okay. Okay. And then we can label where y is positive. Where is y positive? You might look at number 23. Where is y positive? Above the x-axis. So this part up here, this is where y is positive. And this is where y is positive. Okay, and then where is the y value negative? Below the x-axis. Okay. So what should we do next in our picture? What were the numbers that we really needed to have labeled? We needed the x-intercepts. Okay, so let's go ahead and graph this on Desmos because we do need those x-intercepts to do our answers. So y equals x to the 5th minus 2x to the 3rd. Okay, there's our graph. Oh. Okay, so I'm going to label each of these numbers just like I did the previous graph. 1.414, 0, negative 1.414. So if we look at the picture, where does y equal 0? What are they called? Where does y equal 0? At the x-intercepts. So for part A, we're going to be using those points that we drew. Okay, so what are the 3 x values where y equals 0? What are the 3 x values where y equals 0? Yeah, negative 1.414, 0, 1.414. And I'm not worried about writing these like points because they didn't ask what point, like where's the x-intercept, which is a point. They just said, where do you have y values of 0? Where is y equals 0? Where is that happening? So x values only are good answers. Okay. Where is the y value positive? So how are we going to answer this? Just the above the x-axis parts. So I've got to answer this little part right here. And then this part right here. I've got to do my purple. So what should I say for this little piece right here? Okay. And somebody other than Talana tell me why she used parentheses and not brackets. Because she was right to do so. The parentheses were right. So why would she use parentheses and not brackets? Any ideas? If she plugs in these numbers, what's the output? Plug in negative 1.414, what's the output? 0. Plug in 0, what's the output? 0. Is 0 considered a positive or a negative number? It's in between. So we put a parenthesis there because it's like neither. It's like in between positive and negative. Does that make sense? Okay. So that's why we put the parentheses. So that was good. That was good for her to notice that. Okay. Part C. So where is y? Now be careful of this. Less than or equal to 0. Oh, actually, we have one more answer. Sorry. I forgot there was 2 purple ones. So what's the other answer for part B? Uh-huh. Yep. So, and then this one is 1.414 and then right arrow. So this would be infinity. And then since we have 2 answers, what goes in between the 2 answers? A U. Perfect. Okay. All right. For this last one, we have where is y less than or equal to 0? So which part are we going to use for y is less than or equal to 0? The green part. So if we start answering that, what should we say? Any ideas? Uh-huh. And then do we know if that should be a bracket or a parenthesis? So look at this part. It's a bracket. Anyone know why Talana chose a bracket this time? Because it included 0. So if you plug in negative 0.414, you get 0 as the answer. And this one says y can be less than 0, which is the green, but y can also equal 0, which is the pink. So if y equals 0, we put the bracket. That's an actual answer we can have. Do I need to repeat that? Does that make sense? Okay, what's the second answer? Because we got another little green piece, so we got another little answer here. How do we write the second answer? Parenthesis or bracket? Bracket. So they're both brackets because they both have outputs of 0. And so they both have the equal to 0 part. Mm-hmm. Okay. Whew. There is a U between them. Good. I almost forgot that. Okay, that was the most difficult part of the last 2 days. That was it right there. All right, how do you guys feel about that? It's all right? Your brains are okay? Okay. Whew. Okay, so at this point, 1 through 22 on the front side should be completely done. 1 through 22, all the way finished. On the back side, 23 and 25. All right, let's put those off to the side. We are going to do similar types of questions, still using Desmos, but now we are going to do some word problems. Whew. Are you guys ready? You seem so excited. No, that's not happy faces. So sad. Okay, I didn't get all of these stapled, so I'm gonna hand out the stapled copies first, and then I'll send around a stapler. For those of us who I did not staple for. Yeah. I do not. The worksheet. You can do that on a separate sheet of paper. Just use it on Google Classroom. Okay. I skipped you. All right. We ready? You guys can use it after we finish these examples. Okay. So we have two common types of story problems that end up showing up. And one of them is called projectile motion, which is what we're going to go over first. So this says a water balloon was catapulted into the air so that its height in meters after t seconds is modeled by this equation. They say sketch the path of the water balloon on a set of axes before you begin answering the questions. So we're going to go ahead and draw X and Y axes. Now in this problem, they don't use X and Y, but whenever we use Desmos, Desmos is going to force us to use X and Y. And so even though this problem uses other variables, in my head, I'm still going to think of X and Y. So in this problem, they used T. So I'm just going to put that in parentheses that they used T. And then for Y, they used H of T. Okay, so I'm going to put my person who's catapulting a water balloon. They have the water balloon right here. They catapult it. It goes up in the air. It comes down and hits the ground and then splats. You guys like the splat? Is that realistic? Am I a good artist? Okay, that's fine. No support. All right, so here's the highest I don't know, highest point of the balloon, maximum height. Here is where the balloon hits the ground. Here's where the balloon is launched. I think that's all the important information. They say that this is based off the height in meters. So the y-axis is the height in meters. The x-axis is the time in seconds. Ooh, didn't leave enough room. Okay. So there's the picture. Let's go ahead and graph it on Desmos. So now here we're going to have to adjust our window a little bit on Desmos so that we can see stuff in a way that kind of makes sense. And you'll see what I mean in a second. So y equals negative 4.9 x squared. So you're noticing instead of me typing the t's, I'm typing x's. And that's just because Desmos prefers x's, not y's. So I typed the equation. I can't really see anything. Is that true for you guys also? You typed it, you can't really see it. I can zoom out, but like even when I do that, this is not a very nice picture to look at. You guys see that also? Yeah, it's not great. Okay, so what we're gonna do on Desmos is everyone's gonna go to this part right here where it says edit list. And you're gonna click on that. And one of those options when you clicked on edit list is a table right here. So we're gonna click on convert to table. Everyone see that? Convert to table. Okay. Now the reason I'm converting to the table is because it allows me to see the input values and the output values of the table. So I plug in an x value of -2, I can see the y value that it spit out. Plugged in an x value of -1, I can see the y value it spit out. Everyone see that? All of these? Okay. So I can see here 2.4, 24.5, 36.8. I can see that that's the water balloon going into the air. I want you guys to put your cursor right after the 2. And then I want you to press enter, and we're going to keep pressing enter. You can see that the water balloon went up into the air and it's coming back down. We're going to keep pressing enter until we find a negative number. And that negative number is the water balloon hitting the ground. Does that make sense? Water balloon goes up in the air, comes back down, hits the ground. Okay, so what we're doing is when we do the table like this, we are finding good values to set the window on our computer so it's easy to see, so that we're not getting a window that's like a weird shape. So what that means is that for my X values, I should use numbers from -2 to 6. I should use smaller numbers. For my Y values, I'm going to use numbers from like -30 up to something a little bit bigger than +36. So my table helps me use an educated guess for my window so that it's easier to see what's going on. So now I'm going to go over here to the tool. This is my graph settings. And I'm going to take my x-axis, and I just like to do -10 to 10. That's like my normal preference for the x values. I like to do that. And then for the y, I'm just going to change this to -30 to like 50, maybe. And now this is a nice looking graph. I can see it. I'm pretty comfortable with it. I've got exactly kind of what I want there. Does that make sense? We're good with that. Okay. Now, once I graphed it on the table, it gets rid of the equation. Like the way that we typed the equation is gone. So I'm just gonna, you can copy paste this back in if you want to Control C and then Control Z. Oop. Nope. Just kidding. I'm just gonna type it again. I did not want to copy paste on my computer. I don't know if it wanted to on your guys's, but I'm just gonna type this again. The reason I'm typing it again, and I'll show you guys in a second, is that the this one right here, do you guys see how it has purple points? Everyone see the purple points? So the purple points are coming from the table, and they're coming from X values that are a distance of 1 apart. You guys know how on the previous assignment, we were finding things like the mountaintop, we were finding the maximum, we were finding the x-intercepts, the y-intercepts, all of that. The Desmos will not find those for you unless the equation is graphed like this. So if you want to find the x-intercepts, the y-intercepts, the mountaintop, stuff like that, you have to have the equation graphed like normal. It will not find those once you've turned it into a table. Does that make sense? So I want to be able to find these special points, which is why I went ahead and graphed it again, just in case one of those points ended up being an answer. Does that make sense? So I'm just going to graph it twice, once for the table, once for this. At this point, I am now set up to do all of the different types of things that this problem could ask me to do. Okay, you guys ready to start answering some of these questions? Okay, so we're going to go back to the story problem. We're going to label one more thing, and then we're going to start answering questions. So when we do this, we have two coordinates. We have the x coordinate, we have the y coordinate. We know that the x coordinate stands for the time, and the y coordinate stands for the height. So whenever we do any of these questions, we're going to want to figure out if they are asking for us to find a height, which means that somewhere they gave us a time to plug in, or if they're asking us to find a time, which means that somewhere they gave us a height to plug in. Okay, so we figure out what the question is asking, and then we know where to look on Desmos for the answer. So the first question says, what is the initial height? So if they said, what is the initial height? Are we trying to find a y value, or are we trying to find an x value? We're trying to find a y value. And then what does the word initial mean? Say it again. Start. What is the starting height? So if they're saying starting height, what is the x value? What's the time value that you think they gave us? If they want the starting height, what time would they have been giving us? 0. So if they say initial, that means that they gave us an X value of 0. So what we're going to do is we're going to go back to Desmos. And we're going to look, you can look at the table and look at the X value of 0, or you can click on your graph and click where an X value of 0 was, which is the Y intercept. Okay. So look at the table, or you can look at the graph. So the answer for this question, the point is 0, comma 2 point, or yeah, 2.4, 0, comma 2.4. And then we're going to go back and we're going to take that answer, which was the Y coordinate, and we're going to write that answer in a sentence. Okay. What is the initial height of the balloon? The initial height of the balloon is 2.4, and then the units were meters, 2.4 meters. Are you guys good so far? That makes sense? Okay. Yeah. All right, the next one says, how high is the balloon after 1 second? So if it says how high, are you looking for an X value or a Y value? You're looking for a Y value. And then what are you plugging in for X? You're plugging in 1. So go ahead and go back to Desmos. And then what on the screen right now could help us? So we can look at the table, and what value do we have? 24.5. Perfect. So we've got the point from the table. 24.5. And so the Y value is the answer. And now we can go ahead and answer the question. The balloon is 24.5 meters high after 1 second. When she comes back. Okay. The next question says, for how long? For how long? So are they asking us to find an X value, or are they asking us to find a Y value? They're asking us to find an X value. And what Y value did they give us? They gave us a Y value of 30. Okay, now this one is a little different because we don't have anything on Desmos right now that can actually help us with this. So if we want to figure out what the X value is when the Y value is 30, we can kind of see it, right? But it's really hard with your cursor. You guys see how if I was trying to get there, it'd be really hard for me to get to 30 exactly. Everyone see how hard it is to try to move and get to 30 exactly? Does that make sense? So what we're going to do is we're going to graph a new equation, and the new equation is going to be the line 30. Okay, so I'm going to graph y equals 30. Now I can just see where these two lines cross, and I can find the points really easily. Okay, so I'm going to add that to my paper and my notes because that was a nice little trick that made my life easier. So I'm going to say graph the line graph the line y equals 30. Graph the line y equals 30. Okay. Now we have two places where the balloon is exactly 30 meters high. I'm going to go ahead and write both of them down. 1.356 and 4.154. Now, the question said, how long is the balloon more than 30 meters high? So the balloon goes up in the air, it hits 30 meters high. And then here, if we click on this, the balloon is more than 30 meters high. Does everyone see that? 37 meters high, 38, 39 meters high, 38 meters high, 37 meters high. It's more than 30 meters high. And then it hits 30, and now it's less than 30 meters high. So how could we calculate the amount of time that it was more than 30 meters high? We have to calculate the amount of time that it was above. How would we do that? Yeah, we want to see when it started being 30 meters high and when it ended being 30 meters high. We're going to subtract those times, and then we'll know for how long it was 30 meters high. So let's go back to the numbers we wrote on our paper, and let's go ahead and we're just going to subtract them. So we're going to do 4.154 minus 1.356. And I'm not actually going to subtract by hand. I'm going to use my calculator because those are decimals. You could use Desmos too, since that's an actual calculator, but I'm already over here, so I'm going to use this. So I got 2.798. So the balloon was more than 30 meters high for 2.798 seconds. Okay, what is the maximum height? What is the maximum height? Are we looking for a y value or an x value? A y value. Okay. Now, this one doesn't mention any sort of x value to plug in, but we do have a point on the graph we can look at. What is the maximum height? There's no x value to plug in, but we do have a point on the graph we can look at. What point is it? Where would the maximum height be? Yeah, it'd be the very middle of the graph, right up here. So I'm going to go ahead and write down that point. That's called the maximum of the graph. That's the mountaintop of the graph, right? So 2.755, comma 39.594. Okay. What is the maximum height of the graph? And we know that the way they phrase the question, the y coordinate is the answer. the maximum height of the balloon is we only have 5 more minutes. Okay, the next question says when. What are they asking for? An X or a Y? An X. When will the balloon burst as it hits the ground? So if we look on Desmos, what point is that going to be? When will the balloon burst as it hits the ground? Wait, be careful. Because -12 would be under the ground, right? So we want it to hit the ground. What would the ground be? The 0. It'd be the x-axis exactly. Yeah, there we go. So it'd be the x-intercept, 5.598, 0. So the water balloon would burst as it hits the ground. All right, your homework is to finish number 6. Your homework is to finish number 6. And then finish the practice assignment from today. So 1 through 22, 23, 25. 1 through 22, 23, 25. Okay, that's what we're finishing. Tomorrow is the NC check-in. Tomorrow is the NC check-in.